be good. Okay? You have nothing to sphere about this. But sphere itself. Okay? So the volume of the spheres comes from this formula. And what I was telling, what they do in the book, they kind of show that if you were to put a sphere in a cylinder that has this as its diameter, it would take up 4/3. The volume of the cylinder would be 4 pi r cubed, I believe, and they would take up that much. But anyway, another way, the way I do it, and I've done it when I used to teach calculus, which I don't anymore, okay, that if you were, the way they do it in calculus, if this, just to show you, you don't have to write this down, but this is the x-axis, and this is the y-axis. They spin this whole thing around here. So what you end up getting is whole bunches of discs that kind of look like, oh, that's a really bad disc. But you end up getting a whole bunch of discs. And then what calculus allows you to do, it allows you, gives you an algebraic way to add up infinitely many discs, and that's called an integral. And if you find the integral of a circle and you add up the discs from here to here, you will get that formula. And that's basically where that formula comes from rotating a circle around the y-axis. And you'll learn that. Some of you will get big calculus and beyond in this school. And so that's where the formula comes from. All right. So anyway, then it's just kind of plug and chug. So say this is 6, then the volume would be 4/3 times pi, 4/3 times pi times 6 cubed. And that's not the same as 6 times 3, right? That is 6 times 6 times 6, which I believe is 216, yes? Okay, so it's 216.
Yeah.
And I know that 3 goes in there. Do you know how I know that 3 goes in there? Good, yeah, because if you add up the digits, and if the digits are divisible by 3, then the whole number, did you know that trick?
Yeah.
If the digits are divisible by 3, then the whole number is divisible by 3.
Also, if 6 goes into it,
Oh, good point, Makana. Yeah, 6 goes, very good. So Makana is in it right now. Okay, so 3 goes in there 72 times. So the exact answer would be 4 times 72, or 288. Is that right? 288 pi. Okay? And if that's in inches, that would be inches cubed. And they ask you for the nearest tenth, then you plug in pi, but you only do that on pi day. Okay? Then they have another problem. Let's see if I can draw this. I can't draw
I have a
this.
question.
Maybe. Yes?
On Pi Day, do we learn stuff or do we just eat pie?
I have like some word searches about pi and stuff.
And
It's kind
Can
of
that be
fun.
optional?
Optional.
That'd be extra credit.
No such thing as optional.
What
Okay?
about extra credit?
What? Extra credit.
Why is there not such thing as optional?
Do you have to find the thing of the hemisphere now?
I don't believe it. Okay. So,
Can you just divide your answer by 2?
hey, let's see how I'm doing here. I'm doing pretty well. In your book, they have a picture. I'm going to try to draw it.
is it half of a
Okay.
Is it
No, wait. I'm going to use all my geometric tools here. Watch this. Okay.
Mr. Leader, to find the volume of
Whoa. Am I good or what? Okay. It looks like an egg. So, in your book, it's what, something like this?
I think so, like, is it where you try to find, like, the outside of it?
Oh, shoot.
There's
Too bad. I taught you too little, too late.
Yeah.
Oh, well, I don't remember. All right. So, anyway, let me continue.
In the basketball,
So,
a certain size, and then there's the X's on the outside.
So, say they tell you that the distance from here to here is 6, and the distance on the inside diameter is 4. Okay, so I pick better numbers than the numbers that they have in the book. Okay, and you are working at the toy manufacturing store, which makes these egg thingies. Who knows what they are?
Oh, the
And
helmets.
yeah, and you want to know how much volume this will take up. So I'd say this is 6 centimeters by 4 centimeters. Okay? Well, what you have is you have half of a sphere, right? Minus half of a sphere. Do you understand that?
Yes.
Because you want to find the volume of the kind of this part, you know, the 3D part. So it'd be 1/2. So you don't even have to do that. If a whole sphere is 4/3, what would be half? What's half of 4/3?
2/3.
2/3. Okay.
1.5.
So you would have the volume of the inside, or excuse me, the volume of this shaded part is 2/3 pi times what cubed? Not 6. You want the radius, not the diameter.
2, 3.
3 cubed. Okay.
Two.
Minus 2/3 pi times what cubed?
2.
2 cubed, right? Because this is the outside radius, and 2 would be the inside radius. And since you only want half of the sphere, right, it'd be 2/3, not 4/3. That's called the hemisphere, right? So you have 2/3 of pi. Anyone know what 3 cubed is? Hold on, Chris. 27. And minus 2/3 pi times 8. Okay? Which this one comes out nice, right? This is 16. That's, whoops, 18, sorry, right? 18 plus 18 pi minus 2/3 pi, so that's 16/3 pi. So if you want to write this as a nice, beautiful, exact answer, it's 18 minus 16/3 pi. And how many thirds is 18?
6.
Now, 54/3, right? Common denominator?
Oh.
54/3 minus 16/3. Yeah, that's confusing. Equals 54 minus 16. What's that? 38?
Yeah.
38/3 pi. Okay? So that answer would be
Awesome.
38 over 3 pi, which is 12.
36.
12 and 2/3, Josie calls 12 and 2/3 pi centimeters cubed. That's how much chocolate you need to make your half of your Cadbury egg. Or how much filling you need, right?
And proper fraction.
Proper fraction. Okay,
That's proper.
So,
I mean, before.
one more example. Oh, 2 more examples, actually. What was your question, Chris?
I forgot it.
Was it relevant to what's going on?
It was relevant, but I couldn't remember.
Okay, so I'm going to try to draw this one freehand. Oops, did I go way too fast?
Yeah.
Nicole?
That's good.
Okay. So, hey, Ellie, maintain your focus here, okay? One more, 2 more examples. So the next example, I'm going to make a cone, or try to make a cone, not with arrows on the end. A ice cream cone. You like ice cream, right? Here's your
Oh, I'm guessing we're gonna have to find the volume of this.
ice cream cone.
Want to know the
What?
volume of our ice cream cone?
Yes. All right. So,
Rocky Road. You like Rocky Road, Mr. Leader?
I bet you like vanilla.
Why don't you use the circle?
I think the best is strawberry. So.
That is
Strawberry's disgusting. Hey, I'll talk shit this way.
Hey, Neapolitan's
That's
good.
depressing ice cream.
That's the only good strawberry.
Unless it's frozen yogurt.
Mr. Leader's good.
Wait, what
Yes.
did you say?
what?
Ice cream.
Thank you.
Like,
So
what did you say?
here is your ice cream cone, and all you know about this ice cream cone
Coffee ice cream.
is that this is 5. Whoops, I don't want it to be
Flavor
now.
is it?
It's chocolate mint chip.
Is that your favorite?
I don't know. It's pretty. One of
Mint
them.
chocolate.
One of them.
Mint chocolate.
Mint chocolate chip. And this is 2. So they say find the volume. Find the volume of ice cream, because you are opening the new ice cream shop.
Oh, Mr.
Okay.
Weaver, add something. You know how they don't like fill the bottom?
Yeah.
You should like add part of that and then you have to subtract that.
Why would you say that?
What?
It's
I don't remember. Okay, class. So the volume, you want the cone, right? Plus the hemisphere. And if you remember, anyone remember the formula for the volume of the cone?
Isn't it like
1/3 pi r squared h, right? And this is 2/3 pi r cubed, okay? And so r in this case is 2, so you get 1/3 pi times 4 times what?
3,
The height.
2, 5.
Okay. Plus 2/3 pi times 2 cubed, and whatever that comes out to
That's
be.
not very hard. That's pretty easy,
20
actually.
over 3 pi plus 16 over 3 pi, is that
So what if
right?
that simplified to
16 over 3
Oh,
pi,
sweet. It's easy.
which comes out to be 36. Oh, I made up a good problem. 33 pi, which comes out to be 12 pi. 12 pi. We'll call this inches. Thank you. Okay, nice. No applause, please, in the gallery. All right. So the very last problem you're going to see, and this one's hard for me to draw, so don't make fun of me here. Okay. So in this one, I should have just found this one online, but I have to look at the book. So I'm not going to be a very good artist on this one. Oh yeah, I'm going to go like this. Very bad, okay? And then, yeah, it's not very good. And then I'm going to go like, and I'm going to draw in this part. There must be a better way. I'm trying to do it. Right. And then what they do is, this is where it gets tricky. So like this, oops, I don't want that to be done. I want to show the studio audience what I'm doing. Okay. They can learn how to draw out there in TV land. Okay.
Oh, okay, I see what you're doing. I see.
Okay. Wait, I'm missing something.
You have to.
No, it's here. It almost looks like a pack. It looks like
Oh, here we go.
you are. Oh, there it is. Oh, perfect. That was like piece of
Okay. So let's say I have this problem,
maybe like
and say you know that the radius here. Let's say they just tell you this, and this is a hemisphere, okay? And let's say they tell you this is 3, and this angle is 60 degrees, and they say find the volume. So here it gets a little more tricky. So how much of this sphere do I have?
half.
I have half the sphere, so I have 60 degrees. So basically I have 300 3/60ths. Do you understand that?
Yeah, so that's
300 3/60ths
that's
of
30, 36.
of 2/3 because I have a hemisphere, right? 2/3, or you could do. That's right, right?
Close.
Because I have it's half of the entire sphere, which would look like that, right? So times 2/3 times pi times 3 cubed. So 3 cubed.
Can you simplify 330?
Yeah, that's 5/6
5, 6
times 2/3 times pi times 27, and
So
I
it's 4
think-
6ths, right?
Wait, slow down.
You have a common denominator. You just
But it's multiplying.
No, I'm multiplying. So 3 goes in here 9 times. Right?
Yes, sir.
So far, 10, I have 90.
Can you cross multiply to 16?
Yeah, you don't cross
Or
multiply.
cross
Never.
multiply.
95 over 6, which is 45. Pi over 3, which is 15 pi.
Just kidding.
Okay? I'd say inches cubed if that's your. Alright? So that's about it. Alright, your homework is, and I'm going to pass back some stuff to you.
We don't have your class. We don't have your class till Pi Day.
That's your homework, 1 through 911. And then, no, 1 through 9, 11, 13, and 15, okay? That won't be due until Thursday.
Mr. Leader, you mean 1 through 9 and 11?
1 through 9 and 11. Okay?